Here's another stoichiometry problem dealing with gases, reactants, and products. In this case, you have three substances involved in the reaction that are all gases. Okay. The answer, the detailed explanation for solving this problem is given in this link that you can click on if you have the PowerPoint for this. But let me just give you an outline of how to work this. This is best done using the extent of reaction method, using the ICE method. Okay. So what you would do here is you would tabulate, create an ICE table for A, B, and C, and you tabulate your initial conditions. You have initial number of moles of A is 2, and no moles of B at first, initially no moles of C, right? Your changes would be, according to the balance equation, you lose 2x moles of A, you're going to make x moles of B, and you're going to make 3x moles of C. Okay? And so initially, your total pressure, let's just tabulate the total pressure here. Initially, it's 0.5 atmospheres, and our total pressure at the end is 0.800 atmosphere. Okay? So at the end of this reaction, you want to look at the situation at 0.8 atmosphere. When the pressure has reached 0.8 atmospheres, you're being asked for the moles of B, which is going to be x, and the moles of C is going to be 0 plus 3x, means 0 plus x, and moles of A at that point is going to be 2.00 minus 2x moles. Okay? Now, a good strategy for solving this problem is to just say, okay, your temperature here is constant, your volume is constant, okay? So, same temperature and fixed volume container, so volume is constant. So, you remember PV equals nRT, then you can say P equals nRT over V, right? Now, RT and V are constant, so you can say that P over N is equal to a constant, which is equal to RT over V. So you can say then that P1 over, P1 over N1 would be equal to P2 over N2, where N1 and N2 are the total moles before and after. Well, you know what N1 is. It's just 2 moles total, right? P1, you know, is 0.5 atmospheres. P2, the final pressure you're looking at, is 0.8 atmospheres. So you can figure out what N2 is. Well, what happens if you know N2? N2 is just the total moles of gas when the total pressure is 0.8. So N2, as you can see here, is just moles of A that's left, 2.00 minus x, plus moles of B, which is x, plus moles of C, which is 3x. All of this, that would be in moles, is equal to your N2. So you can solve for x. Okay, so I'll let you finish that calculation yourself. If you want more details, there's the link on the PowerPoint to a YouTube video that explains this in detail.